Hello, class. So in this GPS, we're going to look at 39, which is Introduction to Square Roots. So let's take a look at what it means to take a square root. So if we look here, when we look at square roots, what are we doing? To find the square root of a number, right? What are we asking? We're asking what non-negative number times itself equals our number, right? So for example, if you're asked to find the square root of 9, right? That's asking you what number times itself equals 9. And if you know your times tables, right, you know that 3 times 3 is 9. So the square root of 9 is 3, right? Just like if I asked you what's the square root of 25, and I'm asking you what number times itself will give us 25. That's going to be 5, right? And so on, and all the other ones. Okay, so let's look at some examples. And here is a list of a bunch of perfect squares, okay, or square roots, right? So as you can see here, the square root of 1 is 1 because 1 times 1 equals 1. That's why the square root of 1 is 1. The square root of 4 is 2 because 2 times 2 is 4. Square root of 9 is 3 because 3 times 3 is 9. The square root of 16 is 4 because 4 times 4 is 16. Square root of 25 is 5 because 5 times 5 is 25, and so on. Okay, so let's look at some examples. All right, so one of the properties of square roots that we're going to learn is called the product rule. So what the product rule says is that if I have two non-negative numbers that are multiplied under the square root, okay? So if I have two numbers being multiplied underneath the square root, we can split the term into two square roots being multiplied. So as you can see here, if I have the square root of a times b, I can split it into the square root of a times the square root of b. Okay, so let's look at an example. So if I look at the first example, I have the square root of 25 times the square root of 16. So I am able to split them up. I can rewrite this as the square root of 25 times the square root of 16. So I can break them up into their own individual square roots. Because now I would just do the square root of 5, which is 5, times the square root of 16, which is 4. So that would just be 5 times 4, which is 20. That's it. Okay, so same thing with the next one. I have 36 times 49, so I can break them up into their individual square roots. Okay, the square root of 36 is going to give us 6 times the square root of 49 is going to give us 7. So 6 times 7 is 42. Okay, and again, if you forgot what these perfect squares are, right, you can always refer back to this, refer back to the list that we had before, right? Or use your calculator, technically. You can do the radical square root of 36 will give you 6, the square root of 49 will give you 7. Okay, or you can always make a list, right? You can make a list of all the perfect squares, like 1 squared is equal to 1, 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16, right? 5 squared is equal to 25, 6 squared is equal to 36, 7 squared is equal to 49, right? So what does this mean? So these are what's called our perfect squares, okay? These guys are called the perfect squares. So that means the square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. And then the square root of 49 is 7. Okay, so you see how that kind of works, right? You make a list or table, right? You can easily see what the square roots are. Okay, so let's look at another example. Right, so in this example, I'm pretty much doing the same thing. Um, it's going to be 36 times 5. So what do you want to do? Break it up into 36 and radical 5. Okay, so what's the square root of 36 or radical 36? That's a perfect square. That's going to give us 6. And is 5 a perfect square? Meaning, is there two numbers multiplied that give me 5? I mean, well, two of the same number, right? Is there any number multiplied by itself that gives me 5? And the answer is no, right? So if it's not a perfect square, okay, then you just rewrite it as radical 5, and that's it. Okay? So again, what are perfect squares? Perfect squares are, like what the list that we wrote, right? Perfect squares are like 1, 4, 9, 16, 25, and so on, right? Those are our perfect squares, okay? Keep in mind these are the perfect squares. Oops. All right, these are perfect squares. And you get them by doing 1 squared, and then 2 squared, and then 3 squared, and then 4 squared, and then 5 squared, and so on, right? That's how you get those perfect squares, right? So let's look at the next one. Now it's the same thing. I'm able to, since it's multiplication, right? It's 3 times 16. I can break it up into radical 3 times radical 16. Radical 3 doesn't break up, right? So I leave it as radical 3. But radical 16 is 4, okay? And normally you want to put the whole number in the front. So I'm going to put the 4 in the front, okay? So you always want to put the whole number first. So let's get, so the answer is going to be 4 radical 3. All right, let's look at the next one. Okay, so in this example, okay, let's start. In this example, we have radical 18. Okay, now we're going to talk about how to simplify square roots. Okay, now the way we simplify a square root is 18 is not a perfect square, right? Again, what are the perfect squares? Perfect squares are 1, right? 4, 9, 16, 25, and so on, right? These guys are our perfect squares. So when you want to simplify a square root, the question is, what's a perfect square that can go into 18? Okay, you want to break it up into a perfect square. So you want to break it up into 9 and 2. Okay, one of them has to be a perfect square. Which one's the perfect square? 9. Okay, now the square root of 9 is going to give us 3, and then we're left with square root of 2. So that's our answer. That's how we simplify a square root. Okay, technically you might want to say that that is radical 6 times radical 3, right? Because 6 times 3 is 18. But what's the problem with 6 times 3? Well, 6 is not a perfect square, and 3 is not a perfect square, right? So you cannot use 6 and 3. So that's why we got to use 9 and 2, because 9 is a perfect square. So that's why we use 9 and 2, and you cannot use 6 and 3. Okay? So we'll look at some more examples in a few minutes. All right, so let's look at some other examples. So here again, you're asked to simplify this square root, okay? So what you want to do again is you want to think of a perfect square that can go into 8. What's a perfect square that goes into 8? Well, 4 and 2, right? And then the square root of 4 is 2, and then you just have a radical 2. And that's it. Right? The next one, what's a perfect square that goes into 50? If you look at your list, it would be 25 times 2. Okay? Because the square root of 25 is 5, and then you just get radical 2. Now you might have thought about using 5 and 10, right? You might have said 5, radical 5 and radical 10. Because 5 times 10 is 50, right? But what's the problem with 5 and 10? 5 is not a perfect square, and 10 is not a perfect square, so you cannot use that. Okay? Remember, one of them has to be a perfect square. And that's why we chose 25, because 25 is a perfect square. Okay? Let's look at the next one. So we have 20 here. So again, ask yourself, what's a perfect square that goes into 20? And you'll see that that would be 4 times 5, right? And the square root of 4 is 2. And then the square root of 5 is just square root of 5, right? Can't simplify that anymore. And why can't you use 2 and 10, right? Because 2 times 10 is 20. But again, what's the problem? You need to think of a perfect square that can go into it. 2 is not a perfect square, and 10 is not a perfect square. Okay, so you can't use 2 and 10. Right? So maybe you want to pause the video now and try the rest of the problems on your own. Okay, when you're done trying them, you can come back and check your answers. So let's continue. Okay, so we have radical 48 here, right? So again, what's a perfect square that goes into 48? Well, you might say 4 and 12, right? Because 4 times 12 is 48. What happens if I do 4 times 12? The square root of 4 is 2, and then the radical 12 is radical 12. But technically, I can keep going, right? Because can't I also break up radical 12? Yes, I can. Can't I break up radical 12 into 4 and 3, right? Yeah, I can do that, right? And then the square root of 4, and don't forget it's multiplication here because remember, there's no operation between two terms, it's always multiplication. So the square root of 4 is going to give us 2, and then radical 3. And then 2 times 2 is 4, radical 3. So technically, this is your final answer, 4 radical 3, okay? And not 2 radical 12, because you have to break up the 12. So keep that in mind, okay? Now, is there an easy way to do this? Yes, there is. The easy way, right, is that you want to pick the biggest perfect square that can go into 48. What's a bigger number that can go into 48 that's a perfect square? Well, you think of 16, right? 16 times what is 48? 16 times 3 is 48, right? And why did I choose 16? Because 16 is a perfect square. So I can do that, right? 16 is a perfect square. So that's why I choose 16 and 3. Because 16 times 3 is 48. And what's the square root of 16? That's 4. And then radical 3. You see? You actually end up with the same exact answer, right? But what did you notice? If you used 16, you get the answer right away. But if you used 4, you had to do another step, right? You do more work. Okay? So generally, you want to choose the largest perfect square that can divide that number, that can divide the radicand, which is the number inside. Alrighty? Okay, so let's do some more for practice. Alright, so this one. Okay, so this one, we have 3 radical 24. So again, let's just rewrite the 3. That's whole number 3, right? So nothing happens to the 3. Rewrite the 3 whole number. And you want to break up 24. How can I break up 24? Remember, you need a perfect square. So I'm going to use 4 and 6. All right. Now, the 3, nothing happens. Carry the 3 down. And don't forget, it's times. The square root of 4 is 2. So it'll be 3 times 2 and then radical 6. And then 3 times 2 is 6. And then radical. So now the question is, that's actually the answer. The question is, can you break up radical 6? Is there a perfect square that can go into 6? No, right? Because the only thing you can do is 2 and 3 to get to 6, right? But 2 is not a perfect square and 3 is not a perfect square, right? So you can't do that. That doesn't work. That's it. So you leave it as radical 6. That's it. You can't break up radical 6 anymore. Okay? Let's look at the next one. So again, we have a whole number negative 6. So just write the whole number down. Okay, now we got to break up 45. So we got to think, what's a perfect square that goes into 45? Well, you would notice that it's going to be 9. 9 and 5. Right? 9 times 5 is 45. So then what happens? It's going to be negative 6 times radical 9 is 3, and then radical 5. And then you would just do negative 6 times 3, which is negative 18 radical 5. Okay, and that's it. Right? Now, my advice is if you can't think of a perfect square that goes in, right, just go down the list, right? We know that, right? You know how to make the list. It's 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on, right? So basically, use your calculator, right? And these are your perfect squares, right? You want to pick one of these numbers. So you just use your calculator. 45 divided by 40, 1 never helps us. Okay, so never use 1. So you just do 45 divided by 4. Does that work? Nope. Then go to the next one. 45 divided by 9, and you'll see that that works. Okay, so if you have your calculators, just pick perfect squares and just keep trying perfect squares and see which one goes in. Okay. All right, let's do the next one. So here, I'm gonna have again whole number negative 2. So can't do anything with that. Just write the negative 2 down. And I gotta break up 63. So what's the perfect square that goes into 63? Well, you'll see that it's gonna be 9 and 7, right? And then what do we get? Negative 2 times square root of 9 is 3, radical 7. Negative 2 times 3 is negative 6 radical 7. And that's it. Okay, look at the next one. We have square root of 200. So negative, bring down negative, right? Square root of 200. What's a perfect square that goes into 200? Well, you'll find that it's going to be 102, right? And then what do we do? Just bring down the negative, and then the square root of 100 is just 10, and then radical 2. And that's it. Okay. Now, technically, you could have, if you didn't think of 100, technically you could have used 4, right? So you could have broken that up and say that that was 4 times 25, right? Oh no, sorry. 4 times 25 is only 100, right? So that doesn't work. Well, actually, let's use, yeah, technically use 25, right? Yeah, 25 works. Okay, so if you decide to use 25, then you would have gotten 25 times 8, right? So if you thought using 25, it'd be 25 times 8. And then what would you get? That'd be negative 5 times square root of 8. But what's the problem? You can break down square root of 8, right? How do I break down square root of 8? That would have to be radical 4 times radical 2, right? To get it, to get the 8. So that would be negative 5 times 2 radical 2. And then that would give us negative 10, right? Negative 5 times 2 is a negative 10 radical 2. And what do you notice? The answer is the same, right? But what happens? You had to do more work if you chose 25, right? You had to break it up twice. Whereas if you chose the biggest perfect square, like 100, you only got to do once, and that's it, you're done. Okay? So keep that in mind. You always want to pick the biggest perfect square. So I would try bigger numbers first before you try the smaller ones. The bigger perfect squares before you try the smaller perfect squares. Okay, let's look at the next one. All right, so in this example, we're going to look at the quotient rule, right? Remember, the product rule says that if I have A times B, two things multiplying each other, I can split them up, right, into their own square roots. Okay. Now, one thing I want to mention, okay, that I forgot to mention before, is that this rule only applies if it is multiplication. Okay, meaning you see how it's A times B here, right? It's A times B here, right? That's the only time you can split it up, when it's A times B, right? But if, for example, you had the square root of A plus B, right? You cannot split it up, okay? This is not equal to this, okay? This is incorrect what I just did. You cannot do this. Why can't you do it? Because it is addition. Okay, we can't do it because we have this addition sign here. All right, so this is wrong. You cannot split it up this way. If it is addition sign in there, you can't do anything to it. You just leave it the way it is. You cannot split it up into two radicals. Okay, one example you can think about is, for example, if I had radical 9 plus 16, okay, the correct way to do this, right, if I have radical 9 plus 16, right, the correct way is to add the radicals first. So this is equal to 9 plus 16, which is 25, which is equal to 5. Okay, so this is the correct way. The wrong way to do it is, let's say you wanted to split them up, right? If you split them up, what would you get? That'd be 3 plus 4, which is equal to 7. You see? That is incorrect. So this way is wrong. Got it? Because what did I do? I split up that radical. But I cannot. So remember that. You can only split up the radical if it is multiplication. You cannot split it up if it is addition or subtraction. Okay, so keep that in mind. This is wrong. Okay, only multiplication can I split up. Okay, so good. So now that I explained that, we can continue. You're probably going to see the stuff like this later on. Okay, so back to here. So now we're going to look at the quotient rule. Okay, that was a side note. I forgot to mention it earlier. So now back to quotient rule. So basically, quotient rule is similar to the product rule, which says that if I have two things dividing each other, right, I can split it up. I can give each of them their individual square roots. Okay, and remember, this separating of roots only apply if it is multiplication or division. Addition, subtraction, you can't do that. You can't split it up. Okay, let's look at an example. So here we have radical 16 over 25. So what am I going to do? Split up the top numerator and then split up the denominator. Right? Split them up into radical 16 divided by radical 5. So what that give us? Radical 16 is 4, radical 5 is 5. That's it. Next one, same thing. You want to split them up, right? Split up into radical 1 divided by radical 64. What does that give us? Square root of 1 is 1. Square root of 64 is 8. And that's it. Again, you can pause the video now and try the rest of them on your own. Come back and check later. Okay? Let's do some more. All right, let's look at this example. So in this example, you might want to divide, well, this is radical 32 divided by 4, right? So you might want to divide the 4 into the 32, right? But you cannot do that, okay? Why can't you do that? Because that's a whole number 4, okay? This is a whole number 4, and that's a radical 32. You cannot divide a whole number into the radical, okay? So remember that. You can't just divide straight into the radical. So the whole number can only divide a whole number, all right? So what we gotta do is break up the 32. So break up 32, think of a perfect square that can go into 32, the biggest one. The biggest one you can choose would be 16, right? So you would say this is 16 times 2. And then divide that by 4. And then what is the square root of 16? That is just 4. So you would get 4 radical 2, divide by 4. And then what's 4 divided by 4? They cancel, or that's just 1, right? That's just 1, and then radical 2. See? So that's it. That's the answer. Okay. Again, you could have used 4 to break up 32, right? You could have said this is 4 and 8, but then you gotta break up the 8 again. Remember that? So it's more work. So you want to choose 16, the biggest one. All right? So keep that in mind. You can't divide a whole number into a radical. You need to divide a whole number by a whole number. Okay? The radical 16 turned into a whole number, right? Radical 16 turned into the whole number 4. That's why I was able to divide. 4 divided by 4, which is 1. This is an imaginary 1, remember? Okay? Let's do the next one. So pretty much same thing. I can't divide the 6 into the 18. Okay, I had to divide the 6 into some kind of a whole number. So I need to get a whole number out of this so I can divide the 16. So let's break up radical 18. I can break it up into, what's a perfect square that goes into 18? 9 and 2. Divide by 6. So what would that give us? That would be 5 times. Radical 9 is 3. So 5 times 3 divided by 2 over 6, which is equal to 5 times 3 is 15, radical 2 over 6. And now I try to divide the 6 into 15, right? But if you remember, if I cannot divide 6 into 15 evenly, then all I have to do is reduce, right? All I can do is reduce. So again, if I can't divide 6 into 15 evenly, I just reduce. So what do I reduce by? Reduce by 3, right? 3 goes to both of them. So what did I get? Reduce, you get 5 radical 2 over 2. And that's it. Now again, you might be tempted to divide the 2 into the radical 2, right? You might divide 2 into the 2 and say that's 1. Remember, you cannot do that. You cannot divide the whole number 2 into the radical 2. Okay? All right, that's it. Next one. Okay, look at this one. Right, now, for examples like these, okay, my advice is the easiest way to do these, right, since they're both inside a radical, I can multiply them, okay? So my advice is to use your calculator and just multiply. So you would multiply 7 times 42, okay? So you would first multiply 7 times 42, okay? Which would give us, let's just do it over here. You would first do 7 times 42, okay? And don't forget it's over radical 3, right? And again, I'm able to multiply 7 times 42 because they are both inside of a radical. So 7 times 42 gives us 294. But it's still in the square root, right? I didn't take the square root yet. I'm just multiplying inside. So I still have a square root. So that's square root of 294. Divide by, and this is the square root of 3, right? Now I can divide the 3 into 294 because they both have a square root, right? The 3 has a square root, so I can divide into that. So that'd be 294 divided by 3. That would give us 98. The square root of 98. Okay, again, it's still a square root. I didn't take the square root yet. So it's still a square root there. So again, I got 98 by dividing 294 and 3 into 294. Now I gotta think, what's a perfect square that goes into 98? If you use your calculator and you check a few of them, I believe it's 49, right? 49 and 2. Yeah, it works. Okay, so what's the square root of 49? That's 7. And then radical 2. And that's it. So that's your answer. Okay, now same thing with the next one, right? If you look at the next one, you want to do the same thing. You want to just multiply, right? Multiply. You want to say this is 6 times 18 divided by radical 2. Okay, just use your calculator. 6 times 18 gives us 108. So we get the square root of 108. Still square root, right? I didn't take the square root yet. Divide by square root of 2. Now I'm going to divide the 2 into 108. So I still square root, divide by 2. That'll give us 54. Right? Now you want to break up that 54. What does the 54 break into? It's going to break into, what's a perfect square that goes into it? 9 and 6. So what's the square root of 9? 3, and then radical 6. And that's it. Okay, let's look at the next one. Okay, so here, so since they both have a square root, right, you can just divide them, right? So you want to divide here. And you want to say 50 divided by 72. But what do you notice? 72 cannot go into 50, right? So 72, so 72 cannot go into 50. You need to just reduce. So all we can do here right now is reduce. Let's reduce. What can we reduce this by? Let's think. It looks like I can reduce it by 2, right? So let's reduce by 2 first. I can't think of anything else right now. Yeah, I can't think of anything else right now. So I can reduce by 2. So it's going to be the square root of 25 divided by 36. Okay, and now, oh, look at that. They turn into perfect squares. So now I can split them up. So now I can say this is the same as the square root of 25 divided by the square root of 36. And what is that equal to? 5 over 6. Okay, so again, if you can't divide evenly, you just reduce. And next one, same situation here, right? You want to divide the 12 over 48. But 48 can't go into 12. So what do? You just got to reduce. So what number goes into both of them? Well, you can use 12. That's the fastest way to use 12, right? But let's say you didn't think of 12, right? Let's say you thought about using 4, right? So let's reduce by 4. I'm sure most of you probably thought of 4. So I reduce by 4, what do I get? I'm going to get the square root of 3 divided by 12. But now I can reduce again, can't I? Yeah, I can reduce one more time. I can reduce by 3 this time. Okay, so what does that give me? That's going to give me the square root of 1 divided by 4. Now I can split it up. Square root of 1 divided by square root of 4. And what's that equal to? That's going to give me the square root of 1 is 1. The square root of 4 is 2. So I get a half. Okay, and that's it. So again, if you got lost anywhere, just replay the video, watch the video again. And if you have any questions, you can post it on the discussion forum. Right? See you next time.